Welcome back. Today we're going to be looking at the last section of Chapter 2, Linear Inequalities, 2.7. If you look at the textbook, you might see it says linear and absolute inequalities, or absolute value inequalities. We're not going to be covering absolute value inequalities in this video or in this class, College Algebra. But if you were to take pre-calculus next semester, then you would see those come back into play when we study inequalities. Today we're just going to be looking at linear inequalities, and on your homework sets and in your test, you're only going to be tested on linear. So you may see some problems pop up with absolute value inequalities if you're like doing extra problems in your book, or you're watching it on YouTube, or finding some other resource to practice. But just know, for the context of this class, we're only going to be dealing with the linear inequalities. All right, let's go ahead and get started. Today, a quick note before we do. You have coming up, because this is the last section of Chapter 2, a Chapter 2 test. I would highly encourage you to go back through and watch some of these videos, particularly the problems that you had trouble with. Practice the exercises in your homework or out of the textbook, or any problems that you can find to talk to your instructor about, and make sure you master the material in Chapter 2, because you'll be having a test coming up that you'll need to be prepared for. So let's go ahead and get started. We are going to start today. Instead of having a daily Bible verse, I thought this quote was really applicable, because we're going to be venturing into the world of infinity. And as we start exploring, what does it mean to go on forever? How can a thing go on forever and ever and never stop? It kind of is a fun segue into thinking about the aspects of God, the aspects of Christianity that lend themselves to a God who is infinite in many ways, who's infinitely present, and who's infinitely powerful, and who's infinitely wise and all-knowing. We have a God who is infinite in many ways, and this is just one of those ways, counting. We are only going to explore counting to infinity, not all of the ways of God. So A.W. Tozer, who I highly recommend reading anything he's written, says this. He says, "An infinite God can give all of himself to each of his children. He does not distribute himself that each may have a part, but to each one he gives all of himself as fully as if there were no others." And this is just an idea of infinity, and what it means is to have an infinite amount of yourself. It means that you have infinite infinities to give, and it's just a really fun thing to think about as we explore this idea of infinity. So today, let's look at it. Linear inequality, there is a chart in your note set that looks like this. The chart in your note set is really important for you to look at and make sure you know. I'll just point out a few things instead of filling it out and having you watch me fill it out. When you see this parenthesis, it matches the symbol that does not have the line underneath it, which means less than. So when you see a parenthesis, you can think less than. Those two go together. And when you see a bracket that looks like this, you can think of the line underneath, which means less than or equal to, mean including. So the bracket on the right means including B, and the or equal to B on the left means or including B. And so as we explore these things, it'll make a little more sense. But I would encourage you to fill this table out and make sure you understand those concepts. And there at the bottom, you see our ideas of infinity popping up, where if you say, let's just take 1 for example. If you say every number greater than A, well, you start at A, you include A, and then you go on forever and ever and ever. And you take every single number that's possibly imaginable, an infinite amount of numbers, and you include them in this set. So, using these intervals, we are going to indicate all real numbers between and including -3 and 5. So we want to know, this is not 100% clear whether it's including 5 or not. So I'm going to go ahead and caveat this and say including 3 and including 5. Usually you'll have a little more strict language that says including 3 and not including 5 if it's not going to include it. So including 3 means bracket -3, and including 5 means bracket 5. And you'll see that comma is doing a lot of the work there. So every number in between 3 and 5 or negative 3 and 5, which includes negative 2, negative 1, 0, 1, 2, 3, 4, but then also 1.1 and 1.11 and 1.111, and go on forever and ever with this, an infinite amount of times. This interval is telling us we're including every number imaginable, an infinite amount of numbers in between those two numbers, negative 3 and 5. So here we are again. Express all real numbers less than negative 2. So we have negative 2, and we need to go less than that. So we're going to put the comma on the left side. We say every single number in the world down to negative infinity less than negative 2. Or, and that word or there is going to give us this union or unite symbol, or greater than or equal to 3. And there we have every number greater than 3. So if we think about this on a number line, we have a cutoff at negative 2 and a cutoff at 3, and we are including every number in the world, not including 2, starting at 3 and going on forever. And that's kind of what the number line would look like to match that union of two sets. And so we can use these intervals. Those are two examples of just how to write intervals. We can use that interval notation to solve real problems. And the nice thing is the solving is going to happen a lot like every other solving did. We are just going to leave that symbol in the middle and solve this the same way we would solve some of those old style problems, where we add 2 to both sides, and we end up with 3x is less than 3. And then we divide by 3, and we end up with x is less than 1. Sometimes I like to encourage you to put it on a number line so you see what we're talking about. We're saying we're taking this number 1, and we're including every number in the world that is less than that. Well, how do we write that in intervals? We say we start at negative infinity and we work our way all the way up to 1, and then we stop. And so solving these inequalities is a lot the same as solving regular equations. Here we have another example. I'm going to do something a little sneaky so that I can force one rule to happen that's an important rule. So I'm going to solve this equation, and I'm going to do so by moving this negative 4x over. I know usually somebody might have had the idea, hey, let's move the 2x over. I'm just going to do this so we can see this rule happen. So we have 7 is less than or equal to negative 2x minus 3. And then we need a plus 3 on both sides. And we get 10 is less than or equal to negative 2x. And then you probably know what the next step is, which is divide by negative 2. And this is where the special rule comes into play. If we divide or multiply by a negative number, if we divide or multiply by a negative ... we flip the inequality. So what used to say greater than now turns into less than or equal to. We flip it around. And so here we'd still have an x on the right side. We're going to flip that inequality. There's that special rule happening. And we're going to have negative 5. And this says that x is greater than or equal to negative 5. And so we say, what does that look like? Well, that's every number in the world starting at and including negative 5 all the way to infinity, going to the right forever. And that's how you solve linear inequalities. That special rule is written up above, or maybe it's down below, or maybe it's nowhere. Maybe I just wrote it for you. If you multiply or divide by a negative, you need to flip that inequality. All right. I'm going to skip these and leave you to try them. They're very much similar, just they add some fractions into it, but I would encourage you to try this at home. It's going to be the same thing as the one above. You just need to be careful with that negative sign if you happen to flip it. And then this second one, the try at 6, is It's going to be also exactly the same thing, but you're going to get some practice with fractions, multiplying, subtracting, adding fractions, getting common denominators, and combining them. The next type of inequality we're going to do is solving compound inequalities, which is when you see two inequalities in the same equation. How we're going to do this is exactly like we would do a normal inequality. We'll just do it twice at the same time. So here we're going to add 8, but we're going to add it to all sides. And so here we have 12 is less than 2x is less than or equal to 18. And then we're going to divide by 2, and we're going to divide by 2 on all sides. And so we have x is less than or equal to 9 is less than 6. And that rule still applies. Had we needed to flip it, we would have flipped it. If we needed to flip the inequality around, we would have. And what this says is we start at 6 and we don't include it. Notice that parenthesis goes with that less than sign, and this pink or what I haven't done it yet, but this less greater than or equal to sign will tell us to stop at 9, but to include it. So that's where those two symbols are coming from. And remember, the comma is doing all the work. The comma is the thing standing for x in our interval. All of the numbers in between 6 and 9 are represented by that comma sitting in the middle saying everything in the middle also included. All right, we'll do one more compound inequality. Okay, so we're going to solve this compound inequality a lot like we would solve a normal inequality. But first, because you see 3 y's in the problem, I'm going to get those 3 y's down to be 1 y, just combining them, subtracting them. So I'm going to get rid of this y on the right. I'm going to subtract it from the middle, and I'm going to subtract it from the left. And what that's going to do is combine our y's for us. So we're going to have 0 is less than 4. Careful with this. It's going to be minus 8y, because a negative 5y and a negative 3y combined to be negative 8y is less than 5. Then we're going to subtract 4 from all sides. Be really careful with this negative sign too. A lot of times people might take away this middle negative sign. That's not what we're doing. We're only moving the constant. Everything else stays exactly the same. So negative 4 is less than negative 8y is less than 1. And now we're going to divide by that negative 8. And when we divide, that's when our special rule happens. Divide by negative, which means we have to go in and flip the 2 signs that we see. So we have negative 1 over 8, y by itself, and negative divided by a negative is a positive 1/2. And so because this is our last example of this problem set, I'm going to go ahead and put it on a number line for us to show you another way to solve these and look at the interval notation on a number line. I'm going to say which of those 2 numbers is less. Say negative 1 over 8 is less, 1/2 is greater, and I don't include either of them because the symbol doesn't have the underline underneath it or equal to. Neither of them are less than or greater than or equal to, and so we leave open circles there, and we shade in everything in the middle. And everything in the middle is like where your y is. Those are all your potential y values that would make this equation true, or inequality true. And so then we're going to put this in interval notation. We're going to start with parentheses at negative 1 over 8, negative 1 over 8, and we're going to move through the number line until we get to 1/2 and stop. Remembering that comma is doing all the work of representing all of those numbers in between negative 1/8 and 1/2. Thank you for watching this far. If you've watched all these videos, you are now done with Chapter 2, which means you have a Chapter 2 test coming up. I would highly encourage you to review what you can, practice what you can, and not just assume that I watched a video, I'm good to go. Practice through the homework problems. Practice through the try-its that we didn't do in class. Look at the completed notes for solutions to those. Talk to your instructor if you're having problems. But we encourage you in the next few days to complete the test review discussion board. That's going to have each of the students in the class working together to solve some problems, and then to complete your test and do the best on it that you can. Thanks for watching, and I'll see you next time for Chapter 3.